Many scientists were involved in constructing nuclear weapons during World War II, but one scientist, Chien-Shiung Wu, was involved in fuel enrichment or the improvement of nuclear energy. With the development of nuclear weapons came new knowledge about the fuels for nuclear power plants. Have you ever wondered what scientists do to create the fuel for nuclear weapons and power? Chien-Shiung Wu was born May 31, 1912, in Luohu, a place near Shanghai, China. Raised in a family who were strong supporters of education, she put effort into gaining knowledge in scientific areas. Moving to university, she intended to study mathematics, but switched to physics and completed her bachelor's degree in 1934. In 1936, when she was 24, Wu moved to the United States to continue her studies and was offered an opportunity to attend the University of California at Berkeley, with this period of time establishing her as an expert in nuclear fission. Nuclear fission occurs when the nucleus of an atom splits, with the split creating lots of energy. Controlled reactions of this kind are used to make energy in nuclear power plants. Uncontrolled reactions can fuel nuclear weapons. As only uranium-235 isotopes are fissile, or capable of creating fission energy, Wu was recruited to work on fuel improvement for nuclear fission in 1994 for the Manhattan Project, the United States government development of nuclear weapons. An isotope is the name for atoms of elements that have varying mass, and basically breaks down to the fact that not all atoms of the same element are the same isotope. For example, if I had one packet of salt and vinegar chips with 20 chips inside, and a second packet of salt and vinegar chips with 23 chips inside, I still have the same flavor of chips, there is just more in one packet than the other. Wu utilized the process of gaseous diffusion for separating uranium into uranium-235 and uranium-238 isotopes. Diffusion can be defined as the process of matter moving from regions of high concentration to regions of low concentration. An example of diffusion can be seen when pouring cordial into a glass of water. When the cordial hits the water, it slowly spreads to areas with less cordial. Gaseous diffusion occurs through the diffusion of uranium, a solid substance in its gaseous form, uranium hexafluoride. The uranium isotopes of different sizes move at different speeds through a wall with tiny holes, and act like putting big pieces of pasta and small grains of rice through a colander. As a result, more pieces of the small item will be let through the colander, and there will be more rice than pasta on the other side. Uranium-253 is the grain of rice, and the side with the higher concentration of these isotopes is then used as fuel for fission reactions in power plants. In conclusion, without Chien-Shiung Wu's work in developing fuels for fission reactions during the Manhattan Project, nuclear power sources would not be the same as they are today.